What I want to do is to first give you a brief overview on this webinar, also indicating the topics we want to take up this webinar. And I will start with a brief motivation on requirements engineering to show some industry experiences, risks, and also solutions. I will then walk you through requirements engineering from a process perspective, starting with elicitation, covering specification of requirements up to the management and administration of requirements. We will have a brief look into tools. I'm not going to advertise a single tool. This is not my role, and I also see tools always as a support, not as the driver. Nevertheless, if there are questions, we certainly can take them up after this webinar in the chat, which we have embedded at the end. Also, feel free to send me a mail if there are specific questions. I will then finalize with brief summary and also outlook, where is requirements engineering heading. The challenge, which I mentioned already in my introduction before, is that in software-intensive systems, we have a couple of issues which relate to not delivering in time, having budget issues, or more recently when we have global competition, that our productivity is perceived insufficient. Now, having looked to many projects over the last 20 years in very different industries, what I found and what many others have found in this discipline is that often requirements, that is the beginning of the project, are insufficient. And there's a saying which is very briefly, you tell me how your project starts and I will tell you how it ends, which translates into, if you don't do the homework at the beginning of the project, we call that sometimes front-loading, you will suffer later on with a multiple degree. And I come back to these figures because often people ask me what's the ROI of investing into requirements engineering. I think aside from code quality, requirements engineering has the biggest ROI, and for that simple reason it's worth to think what and how to improve in your requirements engineering. We have here a couple of data points which are from different statistics, mostly the Standish group. We have here the 2008 results, the most recent of Standish, looking into some 10,000 projects. And what we see is that about a third is successful, about a fourth is cancelled, the remainder is late or over budget. What is very interesting is if we look to the root causes, both Standish but also industry experts such as Robert Jarrett have found that the primary driver, which is not related to organization and process, is requirements engineering, or if you want, insufficient requirements engineering. So it's certainly worth looking to that, and also looking to the requirements related risks. We have about 10 years ago already looked with two friends, Brian Lawrence and Carl Wiegers, on these requirements risks, and published article with all these experiences in IEEE software. It's still valid, and the interesting part is if we look to the risks, these are probably things which you know pretty well. Missing requirements, that is, we have not enough looked to what are the real needs. We might have looked towards functions which we believe are necessary, but not so much understood what's the customer need. Critical needs overlooked. We might have put the wrong priorities. We might have emphasized some gold plating rather than some very critical functions. A good example which I ran in this week at a customer was a user interface. What happened was that they ran out of budget quite early in the project. They just spent too much on putting a lot of functions together. It was IT project, so the user interface was pretty dominant. And what they did was putting all these use cases together, but not prioritizing in terms of what is a typical approach to handling such a system, which would be look to primary use cases with which the customer would earn his money, and then look also to the primary risks for the user of that system. They basically overlooked that second theme, so they were quite strong on the first one. They had a lot of very elaborated use cases. They did not look too much to misuse cases, such as security-related topics, critical functions, which, if they correlate with other functions, would not work properly. So what happened was that there were 3-4 such cases. So this is when we were called in and had to look into how can we cope with this mismatch. What we found in the end was they could have easily left out a lot of the initial use cases, but should never ever have overlooked these critical misuse cases. So this is what I mean with critical needs overlooked, that too often as software developers, as engineers, we want to be perfect on the functional side, and in doing so we often pay dearly by being imperfect on the quality side, on the risks which clearly on the market are playing a very crucial role. A second theme is wrong requirements. What I mostly see is that people would mix the needs and the solution. There is a huge amount of Dilbert cartoons on that, basically all stating, well, here's the database. Why a database? I need something else. Well, we always do databases. That's the problem which we do, that we just don't look sufficiently towards what are the needs and clearly distinguish the one and the other. So this is why we typically write 2 specifications. One being the external view, the needs, one being the internal view, which is how are we going to deliver a solution. In line with that, inadequate verification, which is that people would not sufficiently try to verify requirements, which, by the way, is the reason why in the course of process steps, which I elaborate later on, I will very much look into how can we ensure a decent quality of requirements. A third risk is changing requirements. That is often unknown baseline. That is, we start with something. I mean, we rarely work from a greenfield approach, so we have some components. Maybe somebody works on tools. He might have Eclipse. Somebody else would work on a database system. He has a previous system. Maybe somebody just reuses specifications, but even that means that we have a baseline. And often we take things for granted which are not anymore valid. We might have not enough time to look to that whole baseline. We have ripple effects. And you know a lot of software projects which ended in big trouble just because the baseline was not known and assumptions were wrong. Along those lines, insufficient change management, that is, requirements change as a rule of thumb. We typically take for granted that you should assume 1 to 3% of your budget being changes on a monthly basis. That can be a little bit more if it's a fast-moving market. It can be a bit less if you are in a full maintenance mode of a rather old legacy system. But generally speaking, this 1 to 3% per month rule holds, and that is over a period of, say, 10 to 12 months, that is 1 year. We should assume that roughly a quarter of all requirements have somehow changed. This is not anymore possible to handle with telephone calls and emails, although some try it. This needs professional requirements engineering, including some type of tool support for bigger systems.